In our presentation, we have 3 common misconceptions, and I will be explaining the first common misconception. If you can see here, it says dilution means removing solute from the solution. So is this statement true or not? Okay, the early statement is actually not true. It's false because in reality, dilution involves adding solvent which only lowers the concentration of the solute. It does not reduce the actual amount of solute. Now, let's start with some situation. Imagine you have a glass of orange juice that's too strong. What would you do to make it milder? You probably add water to it, right? That's how dilution works in chemistry. By adding a solvent, which is the water, to a solution, which is the orange juice, you will lower the concentration of the solute. So the taste of the orange juice is not too strong. But by adding solvent, it's actually only lower the concentration. It does not reduce any amount of the solute. Next, this is the full definition of what is dilution. So if you can see here, dilution means adding solvent while the solute amount stays the same. If you can see at this picture right here, we have 2 solutions, which is diluted and concentrated. So in the dilute solution, it has a less amount of solute but have more amount of solvent. So if you can see here, the solvent is more than the amount of solute. But in the concentrated solution, the amount of solute is more than the amount of solvent. Next, I have prepared 2 simple analogies that can help you guys to understand more about the concept of dilution. So in the first picture, it's a picture of a soup. So let's say you cook a soup and you added too much of salt. Then your soup will become too salty, right? And we don't want to eat a soup that's too salty. So what would you do to make it less salty is you add water into the soup. So water, which is a solvent, can help lower the concentration of salt in the soup. So that's why when you add water, the soup becomes less too salty and you guys can eat it. In the next picture, we have several drinks that are too sweet. So for example, you drink Coca-Cola and it's too sweet, so you add more water, it becomes less sweet. Because when you add water, the concentration is reduced. But you must remember, it only lowers the concentration, but not the actual amount of sugar in the water. Okay, next, this is a simple mnemonic that can help you guys to understand the definition of dilution. So when you think of dilution, you have to think the word add, because dilution is adding. Since dilution means adding solvent, so this mnemonic actually helps you to memorize the definition of dilution. Now, when we already understand about the concept and the definition, now we have to do mathematical calculation to help enhance our understanding about the concept. So in dilution, we have one formula that we use when we want to calculate any question that involves dilution. The formula is M1V1 equals to M2V2. So M1 is initial molarity. That means in your stock solution, it's your first molarity before you add any solvent. And M2, it means the final desired molarity. That means after you add the solvent, that is the final molarity, M2. V1 is the initial volume. initial volume before you add any solvent. And V2 is the final volume after you add the initial volume and the solvent. This equation is used when you have a stock solution of higher molarity than you need, and you need to dilute it to a lower molarity by adding additional solvent. Next, I'm going to present some questions that can help you guys to understand the concept further, and you guys must try to do it as well. The first question is, you have 200 ml of a salt water solution with a concentration of 0.5 molarity. If you add 200 ml of water, what will be the new concentration? So from this question, you actually can find the M1, V1, and V2. It says here, you have 200 ml of a salt water. That means your initial volume is 200 ml. Okay, next, M1. From the question itself, it says with a concentration of 0.5 m. That means you have M1, which is 0.5 molarity. Next, V2 is 200 plus 200. Why? Because you have initial volume 200, and then it says you add 200. That means you add 200 to the initial volume. So 200 plus 200 equals to 400 ml. So the V2 is 400 ml. So by obtaining those information from the question, you put all the information into the formula. So M1 is 0.5 million, V1 is 200 milliliter, and V2 is 400 milliliter. Just substitute the information into the formula, and you will get the M2, which is the final molarity, 0.25 molarity. So the new concentration is 0.25 molarity. So from this question, you can see that the initial molarity is 0.5, right? When you add solvent, it becomes less than the initial molarity. The next question is, a student mistakenly believes that removing solute is the same as diffusion. So, suppose you have a 500 milliliter solution of sugar water with a 0.8 molarity concentration. The student removes 100 ml of solution and assumes this dilutes it. Is this correct? So from our earlier understanding of dilution, the student action of removing 100 ml is actually not dilution, because dilution is you adding solvent, not remove solution. So the solution is, when you remove solution, it will not dilute anything. It only reduces the total amount of solution. The concentration is still the same. Since no solvent was added, so the concentration is still 0.8 molarity. So that's how you solve this question. Okay, this is the last question about dilution. A pharmacist prepares 100 milliliter of a medicine with a concentration of 5 mg/ml. If a patient needs a diluted version with 1 mg/ml, how much water should be added? So from the information like earlier, we have to obtain information from the question. So you have to read it carefully and make sure you write it so you don't get confused which is M1, which is M2, V2. So from this question, it says a pharmacist prepares 100 ml of medicine. So the V2 would be 100 ml with a concentration 5. So the M1 is 5 and V1 is 100. Okay, the next one is, you can get M2 from the question because it says a diluted version with 1 mg/ml. So this 1 mg/ml will be the M2. So from those information, you substitute the information into the formula. So M1, V1 equals to M2, V2. You use calculator and you can get V2, which is 500 ml. So the volume should be 500 ml because you already add the solvent to the solution. This is the last slide of our first one common misconception. The first one is dilution means adding solvent, not removing solid. So this is very important. Please always to make sure remember that dilution adding solvent, not removing solvent, not removing solute, but adding solvent. The next one is concentration decrease, but solid amount stays the same. That means when you add water, only the concentration decrease. The solid amount stays the same. Okay, the last one is real life examples, which is the analogies that I already presented earlier. So make sure to remember it and also do the calculation. So that's all for the first common misconception. Now I will pass this presentation to the next presenter.
Hi, so today I will be explaining the second misconception, which is concentration and soluble are the same thing. If I make my tea super sweet by adding a lot of sugar, does that mean sugar has high solubility? So a lot of people think that concentration and solubility are the same thing. Are you one of them? So I'm sorry to break it to you, but it's actually not true. So today I will be showing you the difference between those two using simple examples and calculations. So what is concentration? Concentration is how much solute is dissolved in a given amount of solvent. It's like how strong or weak a drink is. So let's take a look at example 1. Suppose we dissolve 10 grams of salt, sodium chloride in 500 milliliters of water. What is the concentration? So as we already know, molar mass of an ACl is 58.44. So I'm going to need my team members to pull out the whiteboard. So, next slide. So, as we already know, we need to dissolve 10 grams of salt in 500 milliliters of water. So, first we need to convert grams to moles. So, first thing we need to do is 10 divided by 58.44. So, the answer is 0.171 moles. Next, we need to convert a milliliter to liters. 500 milliliter is equal to 0.5 liters. So, the formula of M is moles of solute divided by liters of solution. So we take this and divide 0.5. So the answer is 0.342 m. So the concentration of this solution is 0.342 m. So we can change this by adding more salt or less salt. Imagine if you're making orange juice. If you add one scoop of orange powder in 1 cup of water, it will have low concentration. While if you put 5 scoops in 1 cup of water, it will be high concentration. Because if you add 1 scoop to a glass of water, the juice is light, while 5 scoops is the opposite. So even if we add 10 scoops, will all of it dissolve? That's where solubility comes in. So what is solubility? Solubility is different. It's not about how much we added, it's about how much can dissolve at a certain temperature. So, the first example, solubility of NaCl at 25 degrees Celsius, 360 gl. So we know molar mass of NaCl is 58.44. So, First, we need to convert grams to moles. We have 360 divided by 58.44. So the answer is 6.1 moles. So at 25 degrees Celsius, the maximum amount as NaCl that can dissolve in 1 liter of water is 6.16 moles. So any extra salt will be staying at the bottom. Have you ever added sugar to iced tea and realized that some of the sugar stays at the bottom? It's because the tea has reached its solubility limit. So, in hot tea, if you put sugar in it, sugar will dissolve easily because in higher temperature, it will have higher solubility. While if you put in iced tea, sugar will sit at the bottom after it reaches its solubility limit because they have lower solubility. The real life analogy is tea and sugar analogy. So concentration is how sweet the tea is, depends on the sugar we added. While solubility is how much sugar can dissolve before extra sugar will stay at the bottom. So concentration is how much solute is dissolved, while solubility is how much can dissolve. So the summary is concentration is amount of solute divided volume of solution, while solubility is the maximum amount that can dissolve. Okay, that's all from me. I will be passing this to the next presenter.
Hi guys, so we are going to dive into the last misconception, which is the third misconception. So nowadays, students always confuse. They think that molarity and molality are the same thing. Yes, molarity and molality both measure concentration, but they're actually different in under certain conditions. So the first one, I would like to explain to you what is molarity. So, as you can see, the formula to find molarity is moles of solute divided by the liters of solution. So, it is clear that molarity depends on volume. So, for example, if you add more solute, for example powder, in a solution, or you reduce the total volume, which is less water in a solution, then the drink will become more concentrated. So, you can see at the simulation that I've prepared. So, from this side. So let's see the simulation together. So here I have a drink mix and also a volume of water. So this is a thing that used to calculate the concentration. So as you can see, as I add more drink mix into the solution, the concentration becomes more high. This is the first condition. And then the second one, if I reduce the total volume of the water, this is 1 liter, right? So if I reduce the total volume of the water, also the concentration will increase. So it is clear that molarity depends on volume of the solution. So next. Okay, this is the example of molarity calculation. So let's read the question together. So you dissolve 10 grams of sodium chloride in 500 milliliter of water. So what is the molarity of the solution? So as you can see in the formula, the first thing that you need to find is the moles of sodium. So how? In the question, it is given that the mass of the sodium chloride is 10 grams. So as you know, that if you want to find moles, you need to divide the mass of the sodium chloride with the molar mass so that you can get the total moles. So here, we divide 10 gram with 58.44 gram per mole, which is the molar mass of the sodium chloride. And then you'll get the moles of the sodium chloride, 0.171 moles. So, moles of solute is done. And then the second one, you need to find the liters of solution. But in the question, it is given in milliliter. So you need to convert the unit into the SI unit, which is liter. So in order for you to get the liter, you need to multiply 500 milliliter with 1000 so that you can get 0.5 liter of solution. So after you get the information, we need to substitute it to the formula. So we divide 0.171 divided by 0.5 liter, and then you get the final answer, which is 0.342 molarity of sodium chloride solution. Okay, so next, I would like to explain about the second one, which is molality. So as you can see, the formula for molality is moles of solute divided by the kg of solvent. So unlike molarity, molality is not depend on mass, and then it is also not changed as the water evaporates. So here's the simulation. Please start the simulation. So here are the simulation. So I try to reduce the volume of the water, which by evaporating the water. So let's see what happened to the molality. First, we need to add a certain amount of copper to sulfate. It is already saturated. And then I evaporate the water, which is the volume of the water will decrease. But the molality stays the same. Why? Because molality only depends on the mass of the solvent. And molality also is more reliable on temperature sensitive experiment. So let's see to the next slide. So here are the example of molality calculation. So same as the previous one, but I changed the previous one. It gives you the liter of the solution, which is the water. But in this question, we give you the mass of the solution, which is 500 grams of water. So the same thing you need to do. First, you need to find the moles of solid, same as the previous one. You need to find, and then you need to divide it by the molar mass, and then you get 0.171 moles. And then you need to convert the mass of the solvent from gram to kilogram, because kilogram is the SI unit. So you need to remember, if you want to calculate something, you need to convert it to the SI unit. Okay? So when you have converted to kilogram, now you can substitute it into the formula. So for the last one, you'll get the final answer, which is 0.342 molality of sodium chloride solution. Okay, next. Here are some real-life application of molality. So, molality helps, and it's also function in antifreeze, because as we all know, molality is not affected by temperature. So it will prevent our cars from freezing in winter. And then the second application is IV fluids. So, molality concept is applied in IV fluids to ensure correct medication doses applied to the patient. Next. Okay, so this is the key takeaways that you can get from the third misconception, which is the molarity and molality. So the first one, molarity change when volume change, like evaporation. Evaporation, as we all know, the volume of the water will decrease. So it will change the molarity. And then the second point that you can get is molarity stays stable because it depends on mass. As for example, you have 1 liter of water. Even if the water will evaporate or something else, but the mass stays the same. So it doesn't affect molality. And also the third one, molality is more reliable in temperature sensitive experiments. As for the previous slide, we can see that it helps our car from freezing during winter, because the solution will not affected by the temperature. So that's all from me. Thank you.